And welcome back. I hope you had some snacks or something. We're ready to go for our next speaker. We want to remind everybody that if you're having some buffering issues, we're having some luck with refreshing the browser. And so everyone is encouraged to refresh their browser and also maybe manually choose their resolution. Our next speaker is Shrey Somaiya, and he's going to be talking about how learning Python helped me, well, that's him, teach C in tertiary education. Shrey started mucking around with Python at high school and is now in second year studying computer science at UNSW. He's currently interning at Westpac. He also tutors at uni and is addicted to gaming. He's a born volunteer, so just tell him that you need his help with something and he'll turn it into a society at uni. So now you can take it away, Shrey.
Awesome. Thanks, Amanda. Cool. So hi, everyone. My name is Shrey, as Amanda nicely mentioned. So this will be quite fast. I'm sorry, but I know you're all amazing people and you'll be able to cope with this speed, I hope. Awesome. Cool. So this talk will go over me briefly explaining my some C concepts and reflecting how my knowledge of Python helped me not only to learn those concepts, but to teach them to new students. So who are you? Hopefully, if you're watching this, you are interested in education and you're interested in Python because this is PyCon and this is the education track. Hopefully, you have some proficiency with Python, mostly variables, if statements, loops, lists, dictionaries, and the basics of object-oriented programming in Python. So who am I? As Amanda mentioned, I've been playing around with computers for a while. My dad used to bring home computers and I would sort of fix them and play around with them and just go out of my way to make trouble. I would often do dumb stuff like write bat files on Windows to display like the matrix code and trick my teachers into thinking I hacked the school computers. And a bunch of other stuff that I was told that I wasn't supposed to talk about because they probably weren't the best idea. I took my first actual computer class in year 7 and we did basic Python things such as learning to print triangles in Turtle. I then chose to pick IST in year 9 and did basics of Python, making some calculators and some more games and small things. I then chose to do software design development for my HSC. Unfortunately, the subject wasn't offered by my school, so I chose to do it via distance education, and I can now confirm I'm a proud alumni of Tara Anglican School for Girls. I then applied for the National Computer Science Summer School and spent 2 years, 2 different summers there. Then I applied for UNSW Computer Science, and now I'm tutoring at UNSW Computer Science, and here we are today. So I'm 19, I'm young. What qualifies me to be talking about the education track? Well, I've been teaching from a young age, whether it was me teaching my friends how to multiply 2 numbers together in year 4, or working at an after-school care for a few years, or teaching uni students in basic programming from Hello World to advanced linked lists. This subject was taught in C, and that was surprising to me when I first came there. So there are no shortcuts to learning, so this talk will start off a little bit slow, but we'll pick up speed with some of the more interesting parts of the talk. So welcome to Comp 1511, UNSW's Introduction to Programming course. This course is an introductory course to the basics of computer science and programming. It's the first course that you'll ever do if you're a computer science student or you're doing a related discipline, i.e. electrical engineering or mechanical engineering. It's intended as an introduction to the field, an introduction to programming, to problem solving, to breaking down programs into code. The topics include fundamental programming concepts, the C programming language, programming style, design, debugging, and testing. I first took this subject in 2019. Well, I should say I only took the subject in 2019. I didn't fail it, thankfully. But my thoughts at the time of looking at this course outline, this course schedule, was what is going on? Why is this course in C? Why is it not in Python? Isn't Python so much easier to teach with? What are data types? What are arrays? I've only ever heard of lists. Are they the same thing? Functions, yeah, I guess so. They sort of transpile from Python. What's memory and pointers? What? Linked lists? I've never heard of half of this stuff, and I've been doing Python for quite some time. And so I was a bit overwhelmed when I first started, all these new words and stuff that I just haven't heard about before. So let's talk about our first C program. And I've hopefully set this up so you can see my screen correctly. So let's look at our first C program. So this is C. C is a procedural programming language, meaning that it doesn't rely on objects such as Python. When I first heard about this, I was super confused. I didn't actually know that was a thing. I didn't know there was anything but object-oriented programming. And so in object-oriented programming, everything's about objects. In procedural programming, everything's about functions and top-down statements. So everything is executed from the top to the bottom, and we always start in the main function. Also, and the most important and frustrating thing is that every line must end in a semicolon. So many times, and I still to this day, I keep forgetting semicolons because I'm so used to programming Python. So in order for us to be able to run a C program, we can't just click run. There's no button or program that will just run our code in one statement. Instead, we use something called a compiler. A compiler is a program that will translate our C code into machine code. Machine code being special instructions that our computer is able to read. So this is our first C program. So let's look at some variables. In C, all variables must be typed. When we declare a variable, we must also declare the type of that variable. So you can see we've got a name variable, which is of type char, character. We have an age variable, which is of type int, integer. And this is our equivalent of a print statement. If you haven't seen these things before, they are akin to Python's format strings back ages ago. But essentially, you can specify what is to be printed. So in this case, %s is a string, i.e. name, and %d is an integer, i.e. age. So let's run this. So we want to use a compiler called DCC, and DCC will take in a C file, and we'll output it to an executable file. Again, a file that our computer can read and run. So if we do this, no output. So that's good. It means it's compiled successfully. Everything's fine. And then we can go /hello world. Awesome. Cool. So this is our first C program. So notably, C is statically typed, meaning that everything we do is checked at compile time. In Python, everything we do is checked at runtime. If you have type errors, you'll go through all what you've done, and then when you get to the error, it'll be like type error. In C, you don't actually execute those lines that are successful. It checks the whole file for any type errors, and then it will error if there is even a single one. So to test that I'm actually not lying to you, let's check this. So here, we're going to try and add 19 to the string hello. Now, obviously, this should fail because we're not JavaScript. You can't add strings and numbers very easily. So let's do this. Yes, I want to save. And let's try and compile again. Cool. So as I said before, DCC is a compiler. DCC is a compiler written by a lecturer, senior professor at UNSW and his team to be a nice little compiler that helps with introduction to programming and helps beginner students understand their code and what's going on. So here it's saying, careful, you can't concatenate values and strings in C using the plus operator, as you seem to be doing in line 9 of hello world.c. So that's really nice. And that's something that we've used at UNSW to help students in this big journey of programming and what it is. Cool. So yeah, that's our first C program. And yeah, when I first taught this to my students, many of them seemed to understand quite intuitively the concept of types. And that was really exciting for me because that was something that took me a long time to learn. Types and the way it operates is very different to Python, which is dynamically typed. Types are changed all the time in Python. So let's talk about control flow. Control flow is the order in which our code is executed. This allows for our code to make decisions from sequential decisions, selection decisions, and repetition decisions. So the syntax of any control flow operator, mainly selection repetition, is like this in C. You have your keyword, so if, for, while, and you have your condition. And then you execute the body. So let's have a look at some basic examples. Selection, if, else. This should be pretty self-explanatory if you've come from a Python background. And for me, when I came from that Python background, this really helped me pick it up. Notably, else if is quite different to elif, but it's close enough that you can sort of understand that it's the same thing. So that was really useful having that Python background to help me learn and pick up this syntax quite quickly. Similarly with repetition, and apologies for the image, it seems to be a bit distorted, but similarly with repetition and loops, you have a while loop, similar as you do with Python. The thing with loops, though, is that there's no direct translation of the for I in range or the iterating over a sequence as we can in Python. We can't do for item in list or for item in sequence because it's just not a thing in C due to the massive amounts of overhead that exists when doing a similar statement in Python. So they're a bit different in C, and so that was a bit of a learning curve, especially the for loop syntax, which is very different in C compared to Python. When you're doing for loop syntax in Python, as I mentioned, you're iterating over a sequence, so you go for item in sequence. But in C, it's something like this, and it's a bit concerning. So loops are a bit confusing, and for me, it took me a while to understand them. So when I would end up teaching this, I sort of relied on my Python background and my knowledge of how Python loops internally work, which for those of you who don't know, Python loops internally work using iterables and the __ get and next methods, or something similar. So the for loop should be broken down to 3 statements. The first one is the forethought. What should be done at the beginning of the loop? So in this case, we want to initialize the I variable to an integer 0. The second area is the condition. When should the loop be running? In this case, the loop should be running between as long as I is less than 10. The third condition is the afterthought. What should happen after each iteration of the loop? After each iteration of the loop, we want to increase this. So when we run this, as some of you might have already guessed, this will just print 0 to 9. Usually in a for loop, this is what you usually do. You can have other cases where you want to do other things in the initialization and the afterthought. But usually this is the case of in loops in this course. Looping was a tough concept for some of my students, especially looping through arrays and looping through 2-dimensional arrays. It was so strange because until this time, they've only ever seen code executing from the top to the bottom. In the case of loops, you go to the top to the bottom, but every now and then the line being executed will move up a bit and you go back to that for loop at the top. And that was quite hard for some students to grasp. Some other students struggle with the concept of x equals x plus 1. In this case, we have I++, which is a similar thing, but I++ is the same as I equals I plus 1. And some students from a mathematical background were super confused. How can I be equal to I plus 1? That doesn't make sense. That's saying 0 equals to 1, 1 equals to 2. That's not possible. And so that was also an interesting challenge to tackle. Cool, so let's talk about arrays. I initially thought that arrays were the same in C as lists in Python, but how wrong I was. In C, much to my surprise, lists are a contiguous allocated segment of memory. Contiguous meaning that all the memory is next to each other. Unlike Python lists, C lists are not self-expanding and they have a fixed amount of elements. They can also only hold one type, which was really annoying at first because I was so used to just chucking everything I needed into a list and using that as my data structure. But in C, you have to be a little bit more careful with what you choose to do. Lists can be indexed the same, which is good, but the hardest thing for me to understand when I was taking the course is the concept of fixed size and type lists. And that was an example of how my Python background actually sort of hindered my learning of this language. Another frustrating part about lists in C versus doing this in Python is that you have no nice functions in C that will help you with these lists. There's no list.sort, no list.append, no list.remove, and so on. The reliance of functions in Python that I've gotten used to, now that they're gone, was just left me struggling. So that was lists. And luckily, when I taught it, I was able to go back and use that knowledge of me struggling to sort of explain to my students, which is really helpful. Let's talk about functions. So functions in Python are quite similar to functions in C. So let's have a look at some functions. I believe I called it, oh, I did. Functions.c, awesome. Cool. So functions in C are quite similar to functions in Python. The only main difference is you have to specify types. As we mentioned before, C is a statically typed language, meaning that you have to specify types for everything so we can check these types and the correctness of these types at compile time. So here we have a function called times2. Times2 will take in an integer x and it will return another integer and it'll be 2 times that number. So here, this main program, and you don't have to understand how this works, but at a top level, it'll ask someone to enter a number. You'll then enter the number, and then it will print out that number times 2 is the resulting answer. So let's see if this works, and I really hope it does. DCC, functions.c, yep, cool. Enter a number, 21. 21 times 2 is 42. Awesome, so that works. But the issue with C is that when you're writing C code, remember everything starts from main. So if I have a lot of functions in my program, as is common with assignments, it gets to a point where I'm marking a student's code and I have to scroll all the way down before I realize what their main body of code is doing. And that's quite annoying and it's quite unintuitive and it's quite unstylistic, I would even argue. So okay, let's just move it to the bottom then. What's the big deal? We can do this in Python. In Python allows us to use functions before we declare them in other functions. And I can show an example of that in a second. But now we can see that my editor is being annoyed, but let's just look at it in DCC. Cool. Implicit declaration, blah, blah, blah. There are several possible causes. You are calling a function named times2 but DCC does not recognize ×2 as a function. How could it not recognize it? I just told it what it was, but it's at the end of the file. The reason being, as I said before, is that C is read top down, so it reads the main file and it reads ×2, and it hasn't seen any of ×2 so far. So this is where a concept called function declarations come in, which allows us to declare that the integer, that the ×2 function exists, ×2. It takes in an integer a, and it will return an integer. So if we do this, it's essentially a prototype saying, hey, I promise you at some point in the code, I will implement this function. Just believe me that it's there. And if you ever need to check the types, this is what it will look like. So we're giving it a little blueprint, a little prototype of what it should look like in the future. So now we run this and we do it again, it should be happy. Awesome. Cool. So something that was a struggle for students to understand was return values and what the concept of return values were. So in this case, I took my Python knowledge and used a Python example to actually show them what return values were and how they worked. So if I go to, awesome. So I used the example of the sorted function. For those of you who don't know, the sorted functions will take a list and it will return a new sorted value of that list. So in this case, we have an unsorted list with a bunch of integers. Again, I made sure to keep it as close to C as possible, as in they're all the same type. And I explained to them that the sorted function will take that list, go away, produce a sorted version, and then give us back a sorted list. And so we got down to this explanation that a return value is essentially me asking someone to do a task and then give me the result of that task, i.e., what's the length of the list? Can you go away and count the length of the list and then give me that number back? And so that's how I use my Python knowledge and my Python experience to sort of teach these students C concepts or programming concepts in general. And that was pretty interesting for me. Yes, that's it for that segment. Strings. Strings are technically not a thing in Python. In C. They are a thing in Python. At least not to the same extent that they exist in Python. In C, strings exist as an array of characters, an array of char types. You can define a string similar to the way we did in our Hello World program, which for memory, I'll bring it up. So here, this is a string, but notably, this is an array. This is an array of 6 strings. And so you might be asking, 6 characters, but why is it 6? My name is only 5 characters long. What happens if I do 5? And the reason with 6 is because everything must end, every string must end with a null terminator. And a null terminator signifies to the computer that that is the end of that string. It is an empty block, it signifies the end. So when we're printing something like %s, instead of printing the whole buffer, so if I did like this much, instead of printing this many characters of random garbage, it'll print the first 5, see it as a null character, a null character, and then it will just stop printing things. So that's why it's one more. But yeah, strings don't exist in C, at least not to the same extent. So strings are in fact an array of characters. When I was learning strings, again, it was really complicated because there's a lack of all these functions. There's no starts with, there's no is in, there's no length, there's no substring, there's no reverse. There's all these functions that I was used to using for C Python strings that just not existent in C. There are some functions in the string library for C, but it's not the same and it's not as intuitive. And in fact, some exercises even banned use of the string library so that you could understand at a fundamental level how strings were stored in memory and how they were used. So yeah, was an interesting time for me. So let's talk about the elephant in the room, structures and memory allocation. So as I mentioned earlier, when I first looked at the course outline, I had no idea what it meant by memory allocation. What is going on? I knew a little bit about objects and garbage collection and stuff like that, but I have no clue. So I don't expect you all to be familiar with memory management or pointers in C. So let's say we can follow along in using comparisons. So here we have, I have to zoom through this. Cool. Here we have a structure object, but it only takes in data. You can only hold data. It's like a collection of data. And so we can set the items in that structure using the dot notation. And so if you run this, it'll print title is how to Python. And so that's a structure. But what happens if we want to do this in a function? If we want to use a function to change the author, well, surely we could just do something like this, microstructs show you something like this, where we have a change author function, again using prototypes we talked about earlier, which will take in a structure book, which we've defined up here. This is a structure book, and it will take in a string author. So here, this should change the author to the author that we give it. So we call the change author function with the author Barnaby, and it should change the author from Mark to Barnaby. So if we run this, DCC struct by you notice it doesn't actually change the final author. It says it is, but it's not. And the reason that is because everything in C is passed by value. So what that really means is that when I create, when I say change author in first book, C will create a copy of first book and send it to the function. And it doesn't actually edit the structure itself in here. It's sort of similar to immutable data types in Python. And the way we solve that is by using pointers. And so stepping back into Python, in Python, we have references. When you create a variable, you create a reference to that object. So when you say a equals to 9, you create a reference to the integer object 9. And so when you pass a to a function, you're not passing a copy of that object, you're passing a reference, a pointer almost, to that object. So when I say times 2 of a, it'll take a reference to the object a, pass it to a function. The function will take that reference a, and it will do some changes on the object at that reference, and then it will return it. In this case, everything in C is passed by value. When you're passing things, it passes a copy of it. So this is quite annoying, and to solve that, we have to use pointers. A pointer is nothing but a type, and it's a type that holds memory. So if we look at a small example, type pointers.c, this is a pointer. So this is an integer, right? To get the reference to a, like we talked about before, we have to use a special syntax. So here we have int star. Int star means this is a pointer, this is a type. The type is int star. What this means is that this type is a pointer star to an integer, right? And the ampersand means get the address of the integer a. So when we run this, it'll say the address of a, blah, blah, and we can sort of determine the address of the variable in memory versus the variable itself. And we can then pass around the address, the reference, like we do in Python, and it's all happy. So that's sort of a little introduction to pointers. I don't want to go too deep into them, but essentially what it ends up with sometimes, because pointers are just types at a fundamental level, you can actually end up with this, where you have a pointer to a pointer to a pointer to a pointer, and it's so messy. And this is some of the code that I've seen in my students' code. So when we teach pointers, we have to teach them responsibly. With great power comes great responsibility. Cool. So I guess the big question that people have asked me is, why do we use, oops, that's not my slides. Why do we use C instead of Python? And this is something I was wondering before. And a bigger question fundamentally is, which language should we use when we're teaching intro to programming in tertiary education? Clearly, it's evident that learning Python before C both helped and hindered my learning of C. In doing so, I was able to understand both Python and C in a deeper level, which allowed me to teach it better. So far, we've gone through my experience of learning C and how I was able to use it to teach C at a better level. But some of the frustrations are clearly evident. So let's have a look at some of the biggest universities in Australia. Monash teaches Python, RMIT teaches Java, USyd teaches Python and C in their advanced stream, USW teaches C in their undergrad and Python in their postgrad. What's going on? Interestingly, CSESOC, the USW Society, ran a discussion on this with lecturers, alumni, and tutors all pitching in. And surprisingly, we had 380 students versus 93 vote for C. And I wonder why. At the end of the day, it doesn't really matter. What really matters is that we're teaching fundamental understandings of programming, of breaking down programs into problems, and computer science. And that's all that really matters. A CS degree aims to equip you with the fundamentals of problem solving and understanding of a computer system. And while I think C is good for that, there are other alternative options, i.e. handwritten binary. So thank you for listening to this talk. I hope this sort of given you some insight into education and how different languages, does it matter, does it not matter? That's a question for you to figure out.
Good job, Shrey. No big hook needed.
We're close.
Just made it. We're pretty close. But you wrapped up admirably. Well done. And I did learn something. You assured me that I would. Shrey is now available to talk in the in the track, in the hallway track. So
Yep.
all of those questions, there were a couple in the stream, so you should hang around so that people can ask them.
Yep.
And to everyone else, please stand by. We'll be back in 10 minutes with our next speaker. Thank you very much, everyone.
Thanks, everyone.